Today's lesson is all about determining if a problem is asking us to find the part, the whole, or the percent. So as we move forward for the next couple of weeks, we're going to be working on percent word problems. And we're going to have to figure out if that problem is asking us to find or compute the part, the whole, or the percent. But there are some reading strategies that we can use to help us figure out for which one we are solving. So, first of all, let's think about what the word part means. Notice I have part there in pink. When we use the word part, I really mean the amount that is being counted. For example, here's the fraction 3/4. Here's a picture of 3/4. If we're talking about the part, let me grab the right color here. Oops, here we go. If we're talking about the part, I can count these green parts, 1, 2, 3. It's the amount that's colored in. It's the amount that I am counting in that picture. There are 3 parts in that circle. In percents, you can typically, but not always, think that it's going to be less than the whole. Especially in 6th grade, a lot of the parts are going to be less than the whole. So if you look at this picture, here's an empty bit. So I needed less than 1 whole circle to show 3 parts. Also, the part can almost always be found before the word is. And right now that's going to seem a little bit confusing, but we're going to go through a couple of examples and it's not going to seem so bad, right? So the number that the part is can almost always be found before the word is. All right, so then let's review what the whole means. The whole is the amount of equal parts in each whole. And you know that Mrs. Toivola has been emphasizing this word each. Not all together, but if I draw one whole, how many parts is it cut in? And if I drew another whole, how many parts is just that one cut in? So looking back at 3/4, if I wanted to find the whole, I would think, well, if I'm going to draw 3/4, I would color in 3, but there are actually 4 in the whole circle. So 4 is the denominator, 4 is the whole. The whole can almost always be found after the word of. Almost always. Very rarely is it before the word of. All right. What about the percent? This one is easier than the other two because the percent usually looks like this. 75 with that percent sign. Or sometimes they'll write out the word percent. The percent is always found before the word percent or the percent sign. The percent will never be found after the word percent or the percent sign. It's always got to be before it. So let's look at some examples. Example number 1. Here is our statement. 10 is 50% of 20. So now you can start to see how the word is and of come into play, right? So again, the statement says 10 is 50% of 20. So if I wanted to find the part is this pink is a signal word for the part. Do you see how the 10 is right next to that word is? The part is almost always going to be in front of or before or to the left of the word is, right? Because I say 10 before I say the word is, that's what I mean, 10 is. If I'm looking for the whole, I'm looking for the word of. The whole is almost always going to be found after the word of. So 20 is our whole, 10 is our part. So if I was going to write that as a fraction, let's start with the other one. 20 is our whole, so I know that's a denominator. 10 is the part. The last thing left here that I have not highlighted is the percent. Usually we're looking for the percent sign and not the word percent, but it could be the word percent. So here is percent, 50%. And we've practiced for the last couple of weeks. I could write percents as the number on top of 100. So if this is a true statement, if 10 is 50% of 20, I should be able to write an equals in between these two and prove that it's true. Well, I could draw an arrow between the 10 and the 5 and say 10 times 5 equals 50. And then I'd have to put that same arrow times 5 equals, and I can double check here. Grab my calculator, bring it up, doop, bring it over. All right, 20 times 5, and when I press equals, it should be 100. It is. So that means that this statement is true. Here's another way that I could think about it. I could think about 50% as being half. So here's a picture of half, and I'm going to prove that 50% is half. I'm going to write 50% again. Let's move it down just a little bit so we're not too distracted. 50% is 50 on top of 100, and I could divide them both by 50. There is a group of 50 and 50. There's one group of 50. Let's use a different color. There's one group of 50. And if I was trying to make $100 using $50 bills, I would need two $50 bills. Hey, look, there's 1/2. So here's a picture of 1/2. And if I look back just for a second, it said 10 is the part and 20 is the whole. So I'm going to write 10 in this blue part. And because it's the same size, that part on the right is the same size as the one on the left, I'd have to write 10 there. But now I want to know how much is in that whole circle. That's 10 plus 10, that's 20. See how we got that 20? 10 is the part that's colored in, 20 is the whole. So 10 is 50% of 20 because 10 is half of 20 and half is 50%. All right, let's look at one more example. Example number 2. Sometimes they write it like this. 25% of 16 is 4. So I'm still going to start with the pink for is equals part. So here's the word is. Now it's at the end. It's is, and what comes after is 4. Now, what's tricky is because the first one, it was 10 is. Now I have the is with the 4. I know that's true because if I look at of, well, I can't go to the left of because that's a percent, so that doesn't make sense. All right? So instead, if I look after the word of, here's of 16, which means 16 has to go with of. 16 has to be the whole. So that 4 has to go with is. And then you can see in the front, there's 25%. All right, so let's try the very same thing. So I have a part and a whole. We know the whole is the denominator, so that's 16. The part has to be the numerator. And what's trickier this time is if I just write 25% next, there isn't an easy number to figure out that goes in between. Because if I did 4 times 6, I'd get 24, not 25. All right? So that means that I have to multiply by a decimal or a mixed number. So instead what I'm going to do is I'm going to think about this a slightly different way. I'm going to move 25 100ths over here. And I'm going to see if I can make a smaller looking fraction. So a number smaller than 4 and 16. So if I divide to make the numbers look smaller, I'm going to try to divide by the number itself. 4 divided by 4 is 1. And 16 divided by 4, I know there are 4 4s in 16. So there's 1/4. Now I can go one more time. I know 1 times 25, that's like having 1/4, that's 25 cents. And 4 times 25 is like having 100 cents or $1. So that means that these two original fractions, 4/16 and 25 100ths, are equivalent. We had to do that middle fraction. All right, but I'm also going to go way back to this idea of 25 hundredths. Actually, here, we have 1/4 is the same as 25 hundredths. So here's a picture of 1/4 in that square. 1, 2, 3, 4. So that's 1/4, right? So if 4 is 25% of 16. And 4, let's see if I can do this in a way that's not too confusing. So I'm looking right up here at this 4. If 4 is the part, then I'm going to put 4 in that part. And all the other same size parts have to have the same number. Now I want to know what's the whole. So if I want the whole, I'd have 4 plus 4 plus 4 plus 4, or I could shortcut and say 4 times 4, and I'd still get that 16. So the whole is 16. The part that's colored in is 4. That was right here. And we know that it's 25% because there are 4 25s in 100.